For these last two simple molarity calculations, I'm going to use liquids with another liquid instead of solid and liquid solutions like we'd used in the previous example. The process is going to be exactly the same. In fact, here's a problem, find a concentration. It doesn't specify what those brackets mean, so it implies molarity. We happen to know that molarity is moles of the solute over volume in liters of the solution. As we look at this, we can highlight some information. It is diluted using water, so water must be our solvent, and our ethanol must be our solute. All right, because the ethanol is diluted by the water. It's mixed with the water. It's dissolved in the water, however you want to say it. We've got our equation. We're going to use it as a checklist. Do I know the molarity? No, that's what I want. Do I know moles of the solute? No, but I've got a volume, so can that get me moles? Yeah, we actually have a density as well, and we're going to get there. So I'm going to put a check mark, but it's going to take more work than the previous problems. Do we know the volume in liter of the solution? Yeah, we know that one pretty quickly. It happens to be 0.500 liters. All right, so when we set this up, 0.500 liters is the denominator. We just need to know that numerator, and that's the only kind of new step in this problem. What we want to work with, we have a volume of our solute, but we want moles of our solute, and to get there we're going to have to utilize both the density and the molar mass. So write our equations, use them as a checklist. Density is supposed to be mass over volume, and moles is supposed to be mass over molar mass. And the information we have at this point in time, do I know the density? Yes, I do know the density. Do I know the mass? No, I have a volume. So I could solve for mass because I know the volume. Alternately, do I have moles? No. Do I have mass? No. Do I have molar mass? Yes. So I couldn't do this. We're going to have to start here. And I'll rearrange that. It's the process you should always follow, which is write your equation, use it as a checklist, rearrange. In this case, mass is density times volume. And now you can plug your numbers in. Our density is 0.789 grams per milliliter, and our volume is 100 milliliters, which conveniently gives us 78.9 grams of our ethanol. All right. And by the way, ethanol, grain alcohol, it's what people drink in alcoholic beverages. It's also used as a gasoline additive in many cases, just to give you some relevance there. Ethanol and water, this could be an alcoholic beverage. Now we want to look at this checklist right here. Do I know the moles? No, but I want to. Do I know the mass? Yes, I just solved for it right there, in fact. And do I know the molar mass? Yes. So we've got this rearranged. Our mass is 78.9 grams, and our molar mass is 46.08 grams per mole. Just so we can kind of see where those numbers came from. This molar mass is what went right there. This density is what went right there. When you do this division, you end up with 1.71 moles of our ethanol. And that number is what we're going to plug in moles of our solute, 1.71 moles. When you plug this into the calculator, you find out it ends up being just double the 1.71, which is 3.42 molar ethanol. That is our concentration of the ethanol. And if you wanted to, certainly you could write C2H5OH instead of methanol. It means the exact same thing. I checked in advance, and I think this ends up about 20% by volume, which would be 40 proof alcoholic beverage, whatever that would end up being, just for comparison's sake on that. As a quick note, this mole number that we had calculated over here is what ended up over there, and then this 0.5 liters is what was used right there. This last example is just an extension of what we saw in the third example. In the third example, we didn't take a solid solute and dissolve it into water or into a liquid solvent. We took a liquid solute, ethanol in this case, and put it into a liquid solvent, water. And then we had to use density to work that calculation. In this example, I took it one step further. I gave you masses of two liquids. Neither of them are water, and we're going to find the concentration, the molarity of one of the liquids, the propylene glycol. Propylene glycol is a fairly common solvent. It's used as a type of antifreeze along with ethylene glycol, but propylene glycol has been in the news lately as a component of vape juice for vaping fluids. Rubbing alcohol is just rubbing alcohol. You've probably got it in your medicine cabinet to sterilize cuts and things like that. So our goal, same idea, let's get a molarity. In order to do so, I'm going to need to write the equation and use it as a checklist. And I'll set it up down here. Our molarity is supposed to be the moles of our solute over the volume in liters of our solution. Okay? Now, there's a very, very, very important bit of information right here. And that very important bit of information is that the volumes add directly. So the volume in liters of our solution is going to be volume of the rubbing alcohol plus volume of the propylene glycol. So we'll get those numbers in a little bit. Do we know the molarity? No. So that's our end goal. Do we know moles of the solute? Well, we actually know mass of our solute, so we can get moles pretty quickly. And then the real hurdle in this problem is coming up with that volume of the solution. And it's just, as I said, an extension of messing around with the densities over there. So let's start out by getting the easier thing, the moles of the solute. I gave all the molar masses and everything else, so that's kind of handy. In this particular case, you have 142 grams of propylene glycol. It is dissolved in the rubbing alcohol, so that gives us a pretty good indication that the rubbing alcohol is our solvent and the propylene glycol is our solute. All right, so we're looking for moles of propylene glycol. I don't know where to set that up. Let's put it right here. We have 142 grams, and we're dividing that by its molar mass, which is 76.09 grams per mole. And we end up with 1.87 moles of propylene glycol, C3H8O2. So that is a number we need. In fact, that number is going to go right there. To get our volume in liters of solution, in fact, I'm going to put the liters on pause. It's going to be the volume of the propylene glycol plus the volume of the rubbing alcohol. And by the way, as you know, these are two very different chemical compounds. Even though the formulas look kind of close, which is kind of a not very sciencey way to say something. Oh, they look kind of close. No, they're totally different. So they do have some things in common, but their properties are wildly different. Don't assume just because their formulas are similar that they're the same thing. Kind of like peroxide, H2O2 versus water, which is H2O. Right? H2O2 is not the same thing as water. In fact, that's a very bad thing. Hydrogen peroxide would kill you. Water is necessary for you to live. They differ by one oxygen. Totally different properties. Same deal here. That's a bit of a side note. All right, so how do we get this volume of C3H8O2? We're going to have to use the fact that we have some densities. Density is mass over volume. Looking at that equation, do I know the density? Yes. Do I know the mass? Yes. So I can solve for the volume. And it turns out then that volume is mass over density. And so that's how we're going to get these numbers right here. I'm going to do the mass of the propylene glycol over the density of the propylene glycol. And I'm going to add to it the mass of the rubbing alcohol over the density of the rubbing alcohol. And let's plug those numbers in and see what we get. The mass of the propylene glycol is 142, and the density of the propylene glycol is 1.04 grams per milliliter. Grams cancel, milliliters will be in the numerator. Our mass of the rubbing alcohol is 713 grams, and its density is 0.786 grams per milliliter. Looking at these numbers real quickly, this ends up, the 142 over 1.04 ends up around 136.5 milliliters. For the rubbing alcohol, we end up with around 907.1 milliliters. And that is around 1044 milliliters, which is still not liters, so we'll call that 1.044 liters of solution. Again, that all hinges on the fact that the volumes add directly, which in real life they don't. It doesn't affect our calculation in this case. In fact, most people wouldn't care, but those volumes don't add directly. But we were told they were, so we can go along with that. 1.044 liters of solution. Now we've got all the numbers we need. Our moles of our solute is 1.87. And again, our solute was that propylene glycol. Our volume in liters of the solution was that 1.044 liters. And when you divide 1.87 by 1.044, you end up with 1.79 molar propylene glycol. And it would not matter if you wrote C3H8O2 or whatever. It's the same thing. I just wrote propylene glycol, so no one looks at the 2 there and misses the 1 there and confuses the two things. So that's how it goes.